Great to meet everybody. We're excited to be here today with WINSYSTEMS. You can go ahead to the next slide for me. As Christine said, my name is Corey Pendleton, and I'm a senior pre-sales engineer here at the Qt company. I've been working with the Qt framework now for almost 10 years, and I'm excited to share how we can help accelerate your time to market along with our partners here at WINSYSTEMS. So here in a few moments, I'll turn it over to GT Hillard and Jack Smith to share more about WINSYSTEMS and how we can work together to build excellent products across multiple different industries. So go ahead to the next slide for me. So Qt has been around for over 25 years. We began in '95 with cross-platform for desktop applications. The dream to write once and run everywhere, although often widely panned, has actually panned out quite well for us. And so for many years, we focused on the desktop platforms and our Qt widgets framework that's been around. Then around 2009 and 10, we began focusing more onto embedded systems. And we brought out our new modern Qt Quick UI toolkit and continued to expand the framework in ways that we could build cross-platform capabilities for desktop as well as embedded systems. Let's go ahead to the next slide for me. And so as we've moved forward into our kind of current state and our future, we've really begun to focus as the UI toolkits matured on how can we improve the life of the developer using the Qt framework, building applications on a day-to-day basis. And so what we put a lot of our emphasis on is how do we improve the flow between the design elements, where your graphic designers and your UX team are building those modern looking user interfaces, into the code and the actual development and hooking into the back end of these devices and then ultimately creating your product, getting it to market. And so with tools like our Design Studio tool, our Boot to Qt environment, I'll talk more about in a moment, and our QA testing tools, we're really enabling you to build your products in parallel, where you used to have to build in sequence, waiting for the UX designs before the UI could begin development, waiting for the UI to complete before you could begin implementing your test plans, and waiting for all of the board support before you could deploy onto hardware. And so that's what we really aim to improve and are continuing to grow in that. Next slide. So the Qt portfolio, as I said, has matured quite a bit over the years. We have design tools now. We have had development tools for some time, and those continue to improve. Our QA tools, with our recent acquisition of our friends over at FrogLogic, bringing the Squish GUI tester and Cocoa tools. All that built on top of the Qt framework that's been established, used in the market across over 75 different industries. Even moving down into the MCU realm to be able to build and load Qt and QML-based applications on the super tiny footprints. In addition, with as a company, we're able to then bring and provide premium support and professional services to help you accelerate your development processes. So all of these things are part of what we can bring to your application and device development. Next slide. So Qt releases are consistent, they're organized, they are quality controlled. We release twice a year, minor releases, in April and September, and every third release is a long-term supported release. And so what that looks like is that you get 3 years of support, backported bug fixes, security patches for 3 years on that LTS version. So here in September of 2021, we just released Qt 6.2, which is the first LTS release in the 6.x family. And so in April, we'll have 6.3 and next September 6.4 before we get to 6.5, which will be our next LTS. But you'll be able to standardize on 6.2 as a standard stable platform for building your applications. You'll have confidence that you'll get security patches over the next 3 years without breaking binary compatibility, and just makes your life a lot more easy as you move forward into the maintenance phase of your projects. Next slide. So we like to say that the Qt framework itself is more than a collection of libraries. So you don't have to go out and find your own serial port driver or your own OPC UA library. But we've provided hooks and abstractions to make it easy for you to use those kinds of functionalities across multiple platforms. And so that's what makes a framework unique. The development idioms are consistent. So as a developer, I don't have to relearn new APIs, new code standards, and adjust as I'm working, but everything is familiar and consistent, and it creates stability in our code base as well. So we have two UI toolkits, as I mentioned. We have widgets and we have Qt Quick. And on embedded devices, Qt Quick is really the toolkit of choice. And even moving into desktops with Qt 6, we begin to bring desktop look and feel into the Qt Quick framework. So you get some built-in themes that feel native on your desktop platforms with Qt Quick. Let's take a look at the next slide. So Boot to Qt, I mentioned earlier, is a tool that we provide for our customers that really accelerates your ability to get your applications onto a device and see them at work early in your development process. So what Boot to Qt is our own custom build of Pocky Linux using the Yocto project. And we're able to incorporate the latest Qt libraries in that build so that you can build your applications. You can simulate and test them on your local desktop using that version, and then you can easily deploy them directly onto the device straight out of the Qt Creator IDE. And so this gives you a lot of flexibility. It enables you to use even our Design Studio tool to deploy QML applications and test them on hardware without having to compile them. So you can create a simulated backend and you can actually get your designs straight out of Photoshop, Sketch, or Figma into code and onto a device, all within a short period of time, talking maybe same day. And then you're able to explore the use case, explore the touch, do user testing, A/B testing early, so that the UX team and the graphics team can begin to iterate on their process. And so these are some of the things that Boot to Qt enables. And we've got a number of boards that we support out of the box that are a part of your Qt license, so that you can get a Boot to Qt image, flash it onto an SD card and run. And as part of our partnership with WINSYSTEMS, we're working together to build Boot to Qt images for the WINSYSTEMS products as well. So they'll share more about that as we move forward. So next slide. And so yes, we like to say that Qt provides a UI technology for every use case. Obviously, we have Qt Quick for embedded and touch-first UIs, modern UIs, Qt widgets for legacy desktop applications that tend to be a little more complex. We have Qt for WebAssembly, which is a fairly new technology, but it's standardized, and we're working to bring your Qt UIs, compile them into WebAssembly to run on a web client. And so this can be handy for headless systems, for remote access, pretty powerful opportunity to use that there, as well as embedded HTML5 with our Chromium-based browser. And with that, I'd like to hand it over to GT with WINSYSTEMS to share more about their products and how we work together.
Hey, thanks for the introduction, Corey. Appreciate it. Yeah. Nice overview of Qt. And so I have the sales and marketing team here at WINSYSTEMS. I've been here for over 25 years. I'll give you a quick overview, and I'll let Jack, our technology director, dive into the details. So you can go to the next slide, Christine. Thank you. So WINSYSTEMS is really about industrial embedded computing. So we've been in this space for coming up on 40 years in January. Our founder came out of not only laying out and designing industrial IO space, but out of the oil and gas industry here in Texas. So using that industrial requirement really drove him to come up with and form the company. So it's in our DNA at WINSYSTEMS to be in the industrial platforms. So we really focus on that. And you'll see from the slide, we're primarily a hardware-based company, and obviously we need software to run on the hardware. What we focus on is really the industrial temperature side of things. So you see all different sizes but we're starting with the board level, and then we expand from there to add the capabilities that we need. So again, we've become a trusted resource for companies over the years. We focus on high reliability industrial grade products that are available for long term. We don't even look at processors that are in the commercial or consumer grade. We look on embedded roadmaps where Intel and AMD and all these guys are doing a great job now, where they come out and it's got a 15-year product roadmap. Those are the products that we want to focus on. Same thing with Qt and their long-term support. We do have our technical staff here. We're all located in Grand Prairie, Texas, which is central in the US. You can go to the next slide, Christine. And so the heart of what we do is really the compute engine. So we're designing from the COM modules all the way up to panel PCs, but it all starts around the CPU level design and making sure we're selecting components that fit that criteria that are going to extend over the time of the product, as well as make it secure and meet the harsh environments that most of our products go into. So we've been in this space for a while. Again, the COM Express is sort of new for us, but we've been in the PC 104, which is in some realms is considered one of the first COM Express modules. Single board computers, panel PCs, and industrial box PCs. And from the overall standpoint of using that technology to drive future demands and long-term availability. We are really focused, and Jack will get into that a little bit later, on the security enabled in our hardware and making sure that our software partners like Qt are helping us to enable that. And again, we focus on a 10-year plus roadmap. So you can go to the next slide, Christine. Thanks. And one of the things that we bring to the design for our OEM customers is being able to really talk to them and consult through the process of selecting not only the hardware, but the software and the development tools that they want to use on their system. And that's where the relationships with companies like Qt come in, and our expertise of having the connections around the industry. So most of the time we'll come in with a multi-tier approach of being the experts on certain criteria from the embedded hardware standpoint, and then bringing in experts that help with packaging or software or different pieces that help the customer get to market quicker. And one of the things that we focus on is really starting with, how do we get this to something to market off the shelf prototypes with a commercial off the shelf solutions, and then make that either modified, because we do our manufacturing in-house, we can take things off or make minor changes. And then if the volumes are right and it's the right application, we actually do a lot of custom designs as well. And we can implement that with our software partners and help customers get to market sooner. Next slide, please. And as we touched on, we're, again, almost 40 years. We're here in Grand Prairie, Texas, which is near Dallas-Fort Worth, centrally located. And there's a lot of technology centers in Texas, and not only in Dallas-Fort Worth, but Austin and this whole area. And so the nice part about being in this area is, from the US standpoint at least, we're able to get to different locations. It's an easy in and out with quick access to the airport. We have in-house engineering and manufacturing. We have our own S&T lines, which not only gives us the capability to do prototypes in-house, but we can ramp that into pretty significant volume production over time. All the departments are here, so we're not always looking to go outside to get support. Our support team, engineering team, manufacturing, everything's here, which really is conducive for production products. You can go to the next slide. And one of the things that we've really focused on the last few years is on the security side. And we've done several other webinars with our partners on this, in making sure that when we're designing the embedded platform, we're focused on industrial from the hardware perspective, because you have to start at the hardware level to make sure that the hooks are there to enable the hardware to be secured. And then the partners come in, we see it over and over again. If you make it easy, people will do it. If it's hard, sometimes they get to the last minute and then they don't secure the hardware. We're seeing it with a bunch of high visibility cybersecurity incidents over the last few years. There's bipartisan support on a Cybersecurity Improvement Act that went through last year in the US. It was signed into law on December 4th of 2020. That's going to help this, and there's going to be continuing to be more support driven for cybersecurity. We think that's going to be key for the future of embedded products. That it includes making sure that the hardware is enabled to develop a root of trust, that you've got secure boot firmware. TPM 2.0 is a requirement on many products, not all, but many. And the software ecosystems around that to do over-the-air updates, security patches, and make sure that you're starting with a program that can do secure communications from the beginning. Next slide. And this is just a sampling. Qt is one of our partners. We have several others that we're working with as well. And we continue, you can watch our website and LinkedIn profiles. You can see the different webinars that we have coming up on security and different embedded features. And next slide. And with that, I'm going to turn it over to Jack, and he can give an intro and get us into more of the technical details. Thanks.
Hi, thank you. DT, I think there's a question to go into as well, so you can look at that, and we'll get back to it in the Q&A. My name's Jack. I'm on the technical side, more of the product development and delivery, in charge of the engineering side of WINSYSTEMS. We've been developing solutions for 40 years. We've delivered literally millions of products and supported those products for decades. So as you can imagine, computing has changed a lot over the last 40 years, and we've seen migrations in performance, features, architectures, and software methods. So one of the ones we're going to highlight today, and one of the use cases we're going to talk about a little bit, is the migration of cross processors from x86 to ARM and being able to support both in parallel. Christine, if you could move forward, please. Thank you. So we've witnessed dramatic changes in the OS layer. Software alone, you used to be able to deliver and develop and deploy once and be done with a product until supply chain squawked at you. But that doesn't work anymore. The ecosystem, the software ecosystem, is alive. It's constantly growing and it's changing. It changes regularly. Some of those changes are at the OS level, like in your graphics engine, your Wayland Weston, or in your subsystems like System D on Linux. Some of those happen quarterly, every 6 months, maybe once a year type thing. But security patches literally come out as a daily event, 0-day patches and things. So change is accelerating. The churn is becoming huge. We want to make sure that churn is a benefit with our customer, not a burden to the customer. I don't want to have to dedicate 20 support resources. I want to be able to automate and have one solution be able to go and move over different places. And so the mix of OSs and the change is becoming significant. If you could move forward, please. And that's where Qt really helps. The Qt framework really helps us bridge between architectures across versions of solutions, etc. We have an example here. Our first interaction with Qt was way back in 2015. We had a customer, they had been buying our products for 20 years, had a huge install base of these products, and we were able to work with them and get them into an ARM-based set of products while still supporting the x86 products by using Qt. They were able to take their platforms, they did all the application coding of the customer directly. They were able to pull their application into a Qt framework. They were able to get it to continue running on the x86 products that were already in the field, and they were now able to support ARM-based products by simply recompiling. It was a huge success for us. A huge success that they did not have to go replace all their old hardware. They were literally just able to do a DevOps maneuver and push into a new stack. So huge success on that one. Go ahead and move forward to the next page, please. That was one example. So I went through that quickly, but I wanted to give you that tangibility before we pull back up to this 10,000-foot level of how the hardware and the framework really work together. So we build rugged security-enabled hardware. It's really important to start with a good basis. It's designed for industrial. We deliver into critical infrastructure. It's got to work. It's got to have a longevity plan so you can buy it for 10 years if you need to. It's got to have a reliability statement. It needs to last. You know, if it's on a train, you don't want to have to go maintain your train every year. But you also, as part of maintenance, you have to provide for security and software maintenance as well. So that's one area. The hardware is a good start. Qt brings down both the development time. We're going to talk about that. If you only have if you're just getting started in Qt and you have a platform that's already integrated into the Qt ecosystem, the Qt tool suite, like the WINSYSTEMS platforms, the onboarding, the learning curve is significantly reduced. Get back to that one. Saw a question pop up. Sorry, I'll get through the slides here and then get to the questions. So the initial development time with Qt, one of the core foundations of Qt is that initial development ramp is very easy. The tools just work. CMake, all the development tools, the IDE, they're best in class. They really make your job easier from deployment or from initial development to debugging. It's all nicely integrated. The libraries support the boards. The framework supports the boards. If you're running one product on one board, it's going to run on another. When we combine those, good hardware and good software, you really get a faster time to market, not just for one device or a small number, and not just the first time. It helps you get started faster, and it helps you maintain your fleet. If you're just going to deliver one board, great, you benefit from the learning curve benefits. But if you have a large number of devices, particularly cross-platform functionality across different heterogeneous mix of devices, you can still have one application core that can run on x86, ARM, Linux, Windows, etc. So, you know, maybe you have smaller devices and bigger devices, performance level variation in your product mix. Maybe you just have generational mixes in there. The ability to cross platforms is huge. It really helps you with both your development and your DevOps piece. And Qt is a huge significant benefit there. Being able to deploy, to reduce the diversity of your development requirements to support those diverse platforms is important. Moving on, 21. So back, yep, that one more forward. There we go. So moving on to one of the pieces of hardware that we can see, a tangible product for us. This is our ITX P444. It's a fully industrial ARM-based architecture product. Very small, standard Pico ITX form factor. Has the flexibility to support and add I/O. We have high-speed PCI Express mini cards slot and USB 3 on the front. There's lower speed ports, including GPIO, I2C, a couple USB 2.0s. It does have a MIPI CSI camera input if you need direct camera to the CPU. There's a TPM 2.0. As GP mentioned, we have a huge interest in security enablement. I want your products to be secure. I don't want, and so I'm going to make that easier for you. Not just with the hardware, there's software enablement to make that easier. You don't have to go learn every piece of the secure boot architecture. We can help you with that and kind of reduce that from a couple months down to a couple weeks in terms of getting that done and delivered. You get to maintain the root of trust. I don't want to own your root of trust. That's on you, but we will definitely help you get the secure product out. Board is also wide power and wide temperature. So full shock and vibe tested, EMI tested, ready to integrate either as a board support or boxed product. So moving on. One of the cases where that board has been used and is deployed in the field at a few thousand locations is monitoring oil and gas fields. So these are remote areas. They're generally caged in with fences. You want to have some capability to understand what's happening in that environment. So we're detecting noise and chemicals and events like traffic or people or gate openings, door openings. There's a video feed. So if an event happens, you can see it. There's an AI engine on there that allows you to say, hey, there's a truck. Well, I was expecting a truck, so don't flag an alert. I was expecting a truck because there was a scheduled delivery because the tank monitor had said it's full, so it needs to schedule a pickup. So these kind of events deployed in the field, remote telemetry, remote communications, they also can take security updates through the over-the-air update frameworks that we integrate with, and provide health and status, not just of the board and the hardware, but also of the environment around them and the facility. Moving on. Okay, that's back over to Corey. I will see you guys again in the Q&A.
Thanks, Jack. I appreciate that. So yeah, we're going to take a look at a quick demo of Qt running on the C444. And we're going to talk a bit about how the Qt QBSP system works, the boot to Qt system. And we'll take a look at how it runs on board. So as Jack mentioned, and I touched on, the boot to Qt system ends up providing you with a complete image, an OS image for your device, as well as the cross-compiled tool chain that you need in order to build for the device. And so what that looks like is you can obtain your QBSP files either directly through the online installer, which is what I'm sharing here. Real quick, are you guys able to see my screen? I'm not sure.
Yes.
Okay, great, thank you. So what you can see here is our online installer. So we have a number of boards supported out of the box. There's additional QBSPs you can download from your account on our website. And in our example, I have the WINSYSTEMS built QBSP for the C444, and that is installed. To do that, to install them, when you obtain them, you download the file. It's an archive. You go to Browse QBSP and locate your QBSP file, select it and open it. That gets extracted and shows up in your installer where you can check what you need. If you don't need to copy the image, you can just get the tool chain, follow through the install wizard to extract it and copy it into your Qt system, and you are ready to go. And what that then looks like is over here in Qt Creator, you end up with a kit, which I'll let it briefly enumerate the number of kits that I have installed currently. And so that kit will include the path to the Qt libraries, the path to the compiler, the cross compiler for the device, in this case, an ARM GCC compiler, and all of the sysroot that's necessary to build your device. So here's the 5.15 build by WinSystems. You can see I've added a device already. We'll take a look at that, but all of the rest of this is pre-filled out for you. So there's no kit configuration that you have to do. It comes ready to go out of the box with the QBSP. So once you have installed it and launched Qt Creator, you need to add a device, which is very simple. You can click on Manage there. You can go Add, and in this case, we could add a generic Linux device, but because Boot to Qt gives us some acceleration, you would add a boot to Qt device, give it a meaningful name and the IP address where it's going to be located on your network, and that's basically all there is to it. Once you add that, we'll do a quick connection test, make sure that all of the hooks are in place, and you're ready to go. So I've already added mine, and we're ready to take a look at that. So what I'm going to show today is a little bit of what Boot to Qt brings to the table. So when you launch a Boot to Qt image, you have some things in place already on the device, an EGLFS application that we run, the Qt launcher. This gives you access to a number of great examples where you can see how well a QML application runs on your device. So for example, we're running at a frame per second indicator up here is 59 to 60 frames per second. We can navigate around and take a look at some of the functionality of QML, how you can do different types of smooth UI transitions, interaction with the screen. We have the ability to grab location data and make use of that. We have a number of other examples in here. So multimedia and graphical effects is part of Qt Quick. So you can take a look at different things, applying graphical effects like glowing, saturation, dynamic effects like wave effects to your images or even videos that play back through multimedia. All of this is enabled through the GPU acceleration that Qt Quick provides. And you can see how well that behaves here on the C444. We also have a great gallery of some of the various controls that you have available. So Qt Quick includes all the standard controls you would expect, and that's a little washed out, but we have buttons, so you can tap on those. You have sliders, dials, progress indicators, page indicators. Let's go for the slider here. So all of the basic controls you need to build a UI, and these are all completely customizable and themable as well. So we have a few custom themes. We have the ability to provide your own graphical assets to replace the standard ones for these controls. And then you can build your own from scratch and just use a template system that we provide to get the API you need for buttons and all of these various controls. I mentioned earlier HTML5 rendering, and so we've got a web browser example on here and a virtual keyboard that you have access to, so you can make use of that, and that can be internationalized for you. It comes with support for multiple languages, as well as even handwriting recognition for a lot of these. So I pulled up our website, and it's a full Chromium-based browser, so you get all the JavaScript functionality that you need. You can see again how powerful the C444 is to run the HTML5 content that quickly. And so that's a great start. And then you're able to just deploy by selecting your kit for a project. So if I take a look at my projects over here in Qt Creator, you can see that we have all my kits are set up here. So I've got a desktop kit here, and then I have my boot to Qt kit for the C444. And you can toggle between those to build and deploy your applications, and it'll SCP them onto the device, execute them on the device, and you can begin working there. If you're working in Design Studio, you can add boot to Qt devices the same way, and they can execute the QML on the device. What we're going to take a look at now is the industrial demo that I mentioned briefly earlier. And so to do that, I'm going to go ahead and pull up my terminal, and I'm going to go ahead and launch that application on the device. So this application actually makes use of an OPC UA connection. I'm going to stop the Qt launcher. And so I'm running the OPC UA server over here on the left. And that's a simulation server for this industrial manufacturing demo. And then on the right, I'm going to launch in my client. So that is, I'm going to give it a platform. So these applications on boot to Qt run, as I mentioned, over EGL-FS, which is the ideal platform for kind of a single purpose embedded device UI. And so I'm also going to pass in a host parameter, which is the IP for my local desktop here, in order where the server is running. And so we'll take a look at the application here running. I'm going to pull in a little closer. And so as you can see, it's in German right now, but I've got the ability to toggle between several different languages. So internationalization is fully supported within the Qt framework. We've even got multiple user selection that you can take a look at different user parameters and priorities to configure different things. We're tracking our statistics through MQTT measurement. And then we have the ability to kick off, manual operation on the hardware device, the theoretical construction device. So I can toggle this part of the construction and manufacturing process, toggle the conveyor, moving this on to the next, and you can see we're using Qt Multimedia to play a live video here. And then I can move over to just automatic running. And so what you can see then on the device is that we're progressing through the different stages of the manufacturing process automatically. As each stage finishes, we're calculating a success, of quality criteria. And so based on a threshold that you can configure in the application, you can actually configure different thresholds in this demo to say, if we don't meet a certain minimum percentage of quality, restart, throw away that batch. Over on the left, you can see the status progressing through the simulator as it sends various state information. And then I can also bring up the same UI here on my desktop. So if I want to execute this locally on my desktop, I can bring up that UI. And what you can see here is that those UIs are synchronized. And so the data coming back from the OPC UA server is reporting back. So we get the same progress through the various states and the same results coming back on success failure data. Boy, 31%, I would have thrown out that batch. So this is an example of a remote UI, again, connecting on to the server, and you can run those servers on the embedded device as well. So if you are wanting to do that, I'm just using it as a remote connection point to see the UI. So I can stop. We can move again into manual mode. We can toggle. So it's all interconnected through that server. So very powerful. So the OPC UA connectivity, we provide direct linking into the OPC UA connection. And so it's pretty easy to configure, pardon my comments, but pretty easy to configure your connections. You get access, create your client class and connect within Qt with signals and slots to get your various status endpoint results and configure those. Passing in your URLs and connection parameters for security is all easy to configure through that Qt library that enables that. And so with that, that completes my demo. I'll go ahead and set us back in automatic mode, and we can move on into the Q&A portion. So questions from the audience.
I saw a couple questions out there that I wanted to address. One of them is the Qt BSP. What versions do we support? Will we support 6.2? I typed an answer, but I also wanted to talk through it. We currently support Qt 5.15, but we have started work on Qt 6.x. That's a more recent delivery from Qt, so we have not finished all the validation on it. We do plan to support that. Work's already started on it. We do plan to support Qt BSPs on our current and future generation of boards. We could go back to older legacy boards if needed, but that would be a discussion with the customers that are already on those boards. We probably would not go back to older legacy boards just by default. So not all of our boards, but certainly our current generation and going forward. So over the past couple of years. There's a follow-up, go ahead and type that in. I think that was from something. And then Christian had asked about operational technology and DevOps. How do you keep a system up to date? It's a really good question. There's a lot of answers depending on how that happens. We go into so many different options. For example, in certain power plants, you can't just go push an update. You have to have somebody walk around to it with an update, and you have to have two people. And so different levels of security require different solutions. My favorite is using secure over-the-air updates through OS tree. You take your Linux operation, your Linux, make a Yocto Linux out of it, minimize that so it's just what you need. And that's basically a container manager at that point. So all of your applications run in containers, your Qt application, your Qt desktop, if you need it, your GUI, your web, all of these are different containers, whether you're an MQTT broker, et cetera. Each container is kind of isolated and modular, and that allows you to do your development in a modular fashion. Each container is kind of independent of the others. It allows you to do your DevOps and your secure over-the-air updates in a modular fashion, so you don't have to push an entire OS image. It helps reduce the attack surface of your Linux, so you don't have quite as many lines of code to review and audit if you're doing security audits. And it can be done in a nice, secure way with continuous integration, such that every time an issue comes out, it goes into your CI pipeline, gets built that night, gets run through your dev tool or your validation tools, your tests, Jenkins or whatever, and then allows you to determine which devices and which pieces of your fleet you're going to go through, whether, hey, I just need to update the ones in this particular region or that particular region, etc. So that's my favorite method. Again, that's a conversation we like to have with the customers to really make sure that we're pulling in the right pieces of the ecosystem for that. WINSYSTEMS doesn't do all those pieces ourselves, but we have partners like Qt that we really like to have help get everybody to the market. So let's see.
All right, thanks, Jack. I can jump in on one that I saw from Kristen as well, which was talking about, it was back when we were looking at what does Qt and WINSYSTEMS, how does this reduce development time? And so I'm not on the technical side as much as Corey and Jack, but just talking to engineering managers, et cetera. I mean, that's really where I get a lot of my input, is what's helping them be successful. And the case that we provided here was a real world case that I was talking to the engineering manager there, and he chose Qt, and this was before we had a strong relationship between the two companies, to work on our hardware. He knew our hardware would work in the field because they were doing oil and gas stuff. They really needed something that they could leverage their code base and be able to run it on x86 and ARM. And the fact that, again, Corey can get into the details of all the pre-certified libraries that they have, their full framework really helped him get to market faster. And they were extremely satisfied with the time that they were able to cut off of their development areas, because previously they had been doing everything in just C code. And so being able to use that library and framework really helped them accelerate their development. And so hopefully that helps solve that or answer that question that you had posted previously. Corey or Jack, do you want to talk about the digital twins question?
Yeah, so the term is not familiar, although I kind of have a guess.
Yeah. I do know the term. Digital twinning is where you're basically modeling a real system in order to help with maintenance, analytics, et cetera. So you create a digital twin of anything from a Boeing engine to a GE, to a wind turbine, et cetera. Helps with the maintenance tasks. Qt can do that. That would require another layer of software. We don't have direct digital twinning to be able to do that modeling. To be able to take the inputs. We can definitely help with the sensor side on the hardware. Qt can definitely help with the integration. There are a number of digital twin packages, but generally at that point, you're going to be talking to a Siemens, a GE, et cetera, or writing your own. So that's a big industrial platform. We love the opportunity. We'd be happy to work with you on that.
One thing I might add to that is that the visualization of those models can be accelerated and supported by the Qt Quick 3D module that we have. So this is where we've worked to bring three-dimensional models into the QML scene graph, and so you're able to visualize them, manipulate them at runtime, modify properties like camera position or zoom level, even light and things like that, all within the application layer. So it gives you a pretty powerful way to visualize 3D things if you're looking at that element of the model, explode it and dig in and select and highlight things in order to view filtered output, for example. But yeah, appreciate your help too on that, Jack.
Okay. There was a question about certifying in Qt in Spanish. You want to take that, Corey or Christine?
Sure. I'm not so certifications can be a big topic. So that's kind of general. Do you have any specific insight other than on what that may mean in this use case, Jack?
Not sure quite, but as a developer, I know there are certified Qt development paths.
Right.
And I think that may be what he was referring to.
Sure. So there's a number of ways you can certify if you're talking about like functional safety. We do that both for automotive as well as industrial medical. So we have those kinds of certifications. If you're thinking about as a developer, being able to certify in the Qt framework, we do have professional services that can provide course content to move towards certification in that framework. I don't know that we have anything in Spanish native at this point, but it's something that we could certainly explore, and I would invite you to reach out to the Qt company. Christine will have an email that we could reach out and we could explore that with you further.
And then the Azure Platforms question, that really depends on where your split is between on-site, on-premise, like at the edge, which is where the WINSYSTEMS platforms would play, and Azure Platforms, which is a lot of times where the maintenance or the data goes. We have an example case there. We're in a lot of rail systems, and so we do the management and monitoring. We will monitor train brakes as they go by. They call them trucks. So we'll monitor the trucks as they go by for heat signatures to detect brakes going bad. Those get sent up to the cloud as flags if they have to stop a car, for example. Similarly with the oil and gas in the deployment, if you see a picture of something that shouldn't be there, that goes up to a cloud. So there is still an Azure cloud side or Amazon cloud or whatever. There is still typically a cloud side. You don't completely get rid of the cloud by having edge capabilities. So it's a good, you get to do more processing and take some of the demand off of the cloud. So you may save money by doing processing at the edge, particularly your AI. If you can do your artificial intelligence or machine learning analysis of your stream at the edge, you don't have to send video up to the cloud and then report back. It saves on communication. It saves on cloud compute. So one option. Again, each product may vary.
Mm-hmm.
I think that's all the questions I see in front of you.
Yeah, I think the last one I see is asking more about costs, and that's going to vary, I think, for each of us and in each use case. So I would invite you to reach out to WINSYSTEMS and Qt account managers to uncover, what that would look like for your use case, and we'd be happy to go over the details with you and get you what you need. Yep, and with that, I think that's it. Thank you so much for joining us. We look forward to hearing from many of you and working with you to build products and accelerate your development experience in the future.
Thanks to our experts, Corey, GT, and Jack, for the very informative session. And thank you all for joining us live. We will be ending today's session. And please note, if you do have any additional inquiries, please contact us at info@qt.io or contact WINSYSTEMS at sales@winsystems.com.